okay, and this is our new video number 27, and this is related to the types of different DC circuits. So I've told you, I've explained it to you that we got two types of circuits. One is called series circuit, and the other one is called as parallel circuit, right? Now, what is a series circuit? We have seen the symbols related to that and everything. In series circuit, if you talk to me like, I mean, if you just say that these are two resistance, they are connected neck to neck, and then along with that, you will have a battery working like this. So, what exactly is happening if you check it out? This is a battery, the current is coming from here, and once it reaches to this point, it has only one path. So, in case of series circuit, a current must have just one path. It has to pass through this resistance, then it can pass through the second. So in series circuit, as the name suggests series, the resistors or particles or whatever are actually connected. You can say just neck to neck, right? So this is what the point is. So this is the series circuit. And what is parallel? Parallel circuit is this. If you just see that, right? This is called parallel circuits. Now, how does it work? Check it out. The current once reaches to this point, right? It will be divided. Some current goes from here, some current goes from here. In the previous one, that is a series circuit, the current is having a one path. In the second case, the current has a multiple paths. So that is a major difference. In series, the current is passed through a single path, while in parallel, the current can have more than one path. So this is the basic difference. Now, let's talk about them one by one. Let's talk about series, right? Now, when you talk about a series circuit, let's have a circuit. These are two resistances. They are connected in series like that. This is R1, this is R2, the resistance, and this is V. Now, let's suppose the current I just reaches to this point. And once it reaches to that, the same current passes through R1 and R2, which means that current passing through R1 and R2 is I1 and I2 are technically equal. So current passing through resistance R1 and R2 are the same current coming out of the battery, which is I in that case, right? This is the first property. Current will be same. Then you have a voltage, right? Voltage is the voltage across the resistance. This is V1 and that is your V2, right? So what exactly is happening? That voltage is divided into V1 and V2. So V is equal to V1 plus V2. So voltage is divided into V1 and V2. Now, one more thing for which we have to actually do the, basically small derivation for. Now, this particular battery is not looking at these two resistors as come one a different separate resistance, but it sees them as a single resistance, and that resistance is called as R effective. But we also called as R equivalent. And what is that value? That's we need to find out, which means that if you replace that two resistance with a single resistance, then what will be the value for that? So R equivalent, what exactly it is. Now, when these two resistances are replaced by a single one, what will be the value for that? So you can use that formula. V is equal to V1 plus V2. Instead of that, what is the value for that? V IRE equivalent. And this one is I1 R1 and this one is I2 R2. And we know that since I is equal to I1 is equal to I2, so IR equivalent is equal to IR1 plus IR2. So IR equivalent is equal to, you're taking I as a common and R1 plus R2. So this I and this I cancel. So you will have R equivalent is equal to R1 plus R. So technically, in series circuit, to find the R equivalent, you just need to add the resistance connected in series and you will get the R equivalent, which means that you can replace all the resistance with that single R equivalent resistance. Let's solve one of the questions. This is one resistance. This is the other one. This is a battery. This value is taken as, let's suppose, 5 volt. R1 is 2 ohms. R2 is, let's suppose, 7 ohms. Now, what you need to find out is V1, V2, I1, I2, and R equivalent. Now, in these questions, the first step is to find out the R equivalent, which is you just replace these two resistances by a single resistance, and the battery remains there. So R equivalent is equal to sum, which is 9 in that case, and that is 5. This is the first step. Now find the total current, which is I is equal to V upon R equivalent. V is 5 and 9. Which is equal to 0.5 ampere, right? Now, once you find the total current, we know that the total current will be passing through each resistor, R1 as well as R2. So, I is equal to I1 is equal to I2 is equal to 0.55 amperes, right? So, what is V1 then? V1 is equal to I1 R1. You can very easily find out that 0.555 multiplied by R1, which is 2. And the other one is V2 is equal to I2 R2. 0.555 multiplied by 7. So what is it? Multiply by 2. That is 1.11. And the other one is 0.55555 multiplied by 7, which is 3.88. If you add them, you will approximately come to the total voltage. So this is how we solve a series. Right? Now let's come to calculation for the parallel circuit. Now how does how does it work? Same two resistors, R1 and R2, are connected in parallel. Right? This is V is equal to 5 volts. This is R1. This is R2. R1 is equal to 2 ohms, while R2 is equal to 7 ohms. For the time being, we're not taking any values because the first thing is to find out the equivalent resistance of a parallel circuit. Now, as we discussed previously, that in a parallel circuit, the current will be technically divided into I1 and I2. So, I will be equal to I1 plus I2. Secondly, this voltage is the voltage that is across this resistance as well as this resistance. So in this case, in parallel circuit, V is equal to V1 is equal to V2. So what exactly in the parallel circuit is? the current I that is coming out of the battery is divided amongst the resistances which are connected in parallel circuit, and the voltage is the total voltage of a battery, which is equal to the voltage across each resistance. Now, how to find R equivalent? So we know that I is equal to I1 plus I2. So you replaced it, and that is your V, right? So what exactly is the same? Now we know that V upon R equivalent, V upon R equivalent. Now this voltage is same for all the, all the voltages. So V upon R1 plus V upon R2. Now you can just take V as a common. So 1 upon R1 plus 1 upon R2. This V cancel, and you got a new formula. Did you notice that it's not always sum? The resistance is not always sum. So R equivalent is equal to 1 upon R1 plus 1 upon R2. This is the combined effect of the both resistance which are connected in parallel. Or if you further dig into that, then you will have a volt. I mean, you can find out the resistance as R1, R2, and R1 plus R2. So R equivalent R1 into R2 divided by R1 plus R2. So in parallel circuit, you will have that equivalent resistance. Let's solve one question, then you will understand it. These are the two resistance. This is R1. This is R2. This is V. 5 volts. R1 is 2 ohms. R2 is 6 ohms. Now we need to find same V1, V2. I1, I2, and R equal to, right? These are the things you need to find out. Now, how to do this? First of all, we know that V is equal to V1, V is equal to V1 is equal to V2. So you can find I1 value as V1 upon R1. So 5 divided by 2, which is 2.5. And I2 will be equal to V2 upon R2, which is 5 divided by 6. Which is 0.83 amperes. This is the current value. Here you do not need to find R equivalent in the first place, right? Now what is the voltage around? Voltage is same. We know that V is equal to V1 is equal to V2 is equal to 5 volts, right? Now what is R equivalent? So the formula is R1, R2, so it will be 2 multiplied by 6 divided by 8. So 12 upon 8. This is the R equivalent. 12 divided by 8 is 1.5. That is the combined resistance in the parallel circuit individually. Now let's solve a question where you may have series circuit. Along with that, you have a parallel circuit, a combined effect, right? This is the circuit. Now, what are each circuit do? I mean, what is series and parallel in that? R1, R2, R3, V. V is equal to 5 volts. R1 is equal to 2 ohms. R2 is equal to 3 ohms. And R3 is equal to 5 ohms. Let's talk about this. We have to find V1, V2, V3, I1, I2, I3, and R equal. This is a question, and that question we will start solving the combinational question. This is one of them in the next session. So hope you understand series parallel circuit. So this question, and along with that, there are some one or two more topics we will do in the next lesson. And hope to see you in the next lesson, which is lesson number 28. All right. Thank you for watching. Bye.